Good morning students. Today we are going to learn about how to write the Vhdl program for decade counter and Johnson counter. Okay. So this is the Vhdl code for decade counter. All of you know that decade counter counts from 0000 to 1001. Okay. Again it restarts from 0000. So decade counter counts from 0 to 9. 0000 to 1001. Okay. Decade counter is also known as mod 10 counter. Okay. We have 10 different output states. Hence it is called mod 10 counter. Okay. So this is the Vhdl code for decade counter. Okay. In every program we have library, entity and architecture part. Okay. So totally 4 bits. So this is 4 bits counter. So here you have to use 3 down to 0. Okay. So now entity part. In entity part, the first line is entity name is, in this program decade counter is the entity name, behavioral is the architecture name. In counter we have the input, clock and reset. So code to open the bracket, clock, comma, reset, both are single bit. So you have to write std logic, both are input, so you have to use mod n, semicolon. Next I am declaring count. Count is used as input as well as output, so you have to use mod in out. Okay. Count colon in out, 4 bits length, so 3 down to 0. Here you have to use std logic vector. If it is single bit, you have to use std logic. Okay. So 4 bits data. So std logic. You have to use std logic vector. Okay. In the entity part, the third line is end entity name. In this program, entity name is decade counter. So end decade counter, semicolon. Next architecture part. In the architecture part, the first line will be architecture name of entity name is. In this program, behavior is the architecture name, decade counter is the entity name. So architecture behavior of decade counter is. Next you have to use begin, so I am writing begin. In this program also I am using process and if statement. Okay. Process, open the bracket, clock, reset. If any changes occurs in the clock or reset, it will execute the statements inside the process. So I am using clock and reset in the sensitivity list. Okay. Process, open the bracket, clock, comma, reset. Next you have to use begin. Now I am checking reset. If reset is equal to 1, then 0000 will be assigned to count. Okay. In counter, first we are clearing the flip-flops. Okay. So first we are checking whether reset is equal to 1 or not. If reset is equal to 1, 000 will be assigned to count. if it is not true. That means if reset is equal to 0, then it will execute the statements inside the else. Okay. Now it will check the clock. If the clock moves from 0 to 1, then it comes to here. Now it will check the count value. Okay. In decade counter, it should count from 0, 0, 0, 0 to 1, 0, 0, 1. After that, it comes to 0, 0, 0. Okay. Again, it will restart from 0, 0, 0. So, after reaching 1, 0, 0, 1, sorry, when it reaches 1, 0, 1, 0, you have to clear the flip-flops. Okay. So, for that I am using, here I am checking whether the count reaches 1, 0, 1, 0 or not. Okay. If count is equal to 1, 0, 1, 0, so you have to clear the flip-flop. So, count is equal to 0, 0, 0, 0. Now, it restarts from 0, 0, 0. Again, the count will be incremented for each clock pulse. Okay. So, first I am checking reset. If it is 1, the count is assigned to 0, 0, 0 is assigned to counter. If reset is equal to 0, then it will check the clock. If the clock moves from 0 to 1, again it will check the count. If the count reaches 1, 0, 1, 0, you have to clear the flip-flop. So, I am assigning 0, 0, 0 to count. When the count reaches to 1, 0, 1, 0. Otherwise, it comes to here. It will execute the statement inside the else. If it not reaches 1, 0, 1, 0, count will be incremented by 1. Okay. So, first we are checking the reset, then clock, then count. Okay. If the count is not equal to 1, 0, 1, 0, then the count is incremented by 1. Okay. For every clock pulse, the count is increased by 1. When it reaches 1, 0, 1, 0, 0, 0, 0, 0 is assigned to count, then it restarts from 0, 0, 0. Okay. So, this is the end for this if statement. This end for this if statement. This end is for this if statement. Okay. Now, I am closing process statement. End space process. In the last line, I am using end behavioral. Okay. I am closing architecture. So, architecture name is behavioral. So, end behavioral. Okay. So, this is the Vhdl program for decade counter. Next, we will see how to write the Vhdl code for 4-bit Johnson counter. Okay. In Johnson counter, what is the connection? So, the output of last flip-flop is connected to the input of first flip-flop. Okay, the output of last flip-flop is given to the input of first flip-flop. Okay. This is the Vhdl code for 4-bit Johnson counter. In every Vhdl program, we have library, entity and architecture part. Here also, we have clock and reset. Both are input. So, colon n, both are single bit. So, STD logic. Next, I am using output q, or you can use count. Okay, any variable you can use. Q is output. So, q colon out 4 bits data, so std you have to use std logic vector 3 down to 0. Third line is end entity name. In this program, Johnson counter is the entity name, behavioral is the architecture name. So end Johnson counter. Okay, next architecture part. In the architecture part, first line is architecture name of entity name is, in this program Johnson counter is the entity name, behavioral is the architecture name. So architecture behavioral of Johnson counter is. Next I am using temp as the variable. Okay, so syntax for variable declaration is variable. Next you have to write the variable name. That variable name is temp colon 4 bits data. So you have to use std logic vector 3 down to 0. Okay, then next you have to use begin. Okay, in this program also I am using process and if statement. If any changes occurs in the clock or reset, it will execute the statements inside the process. So you have to write clock reset in the sensitivity list. Process opening bracket clock comma reset. Okay, next you have to use begin. Here also I am checking reset in the beginning. So if reset is equal to 1, then temp is equal to 0 0 0. Okay, in the beginning I am assigning the values to the temp. Finally I am changing this temp value to the output queue. Okay, so this is variable, so you have to use colon equal to. Please note it here. If it is signal or out, then you have to use less than equal to. Here temp is variable, so here you have to use colon equal to. Okay, so 0 0 0 is assigned to temp. If reset is equal to 0, then it will execute the statements inside the else. Okay, now it will check the clock. If the clock moves from 0 to 1, then temp of 0 is assigned to temp 1. Sorry, temp of 3 is complemented. So in Johnson counter, in ring counter only the output of last flip-flop is connected to the input of first flip-flop. In Johnson counter, the complemented output of last flip-flop is given to the input of first flip-flop. Okay, sorry. So now temp 3 is assigned to temp 0. Temp 0, temp 1, temp 2. Correct. Okay. So now temp 3 is complemented. That complemented value is assigned to the temp 0. Temp 0 is shifted to temp 1. Temp 1 is shifted to temp 2. Temp 2 is shifted to temp 3 for every clock pulse. Okay, this is the end for this if statement. This is the end for this statement. Now I am closing process. The final temp value will be assigned to the output queue. Okay, in the last line I am closing architecture. So end behavioral is the architecture name. Okay, so in Johnson counter, the output of the complemented output of last flip-flop is given to the input of first flip-flop. So not temp of 3 is assigned to temp 0, temp 0 is assigned to temp 1, temp 1 is assigned to temp 2, temp 2 is assigned to temp 3. Okay, thank you.